Today I'd like to introduce our latest creation, the SmartLamp Controller. It's an Arduino-compatible board with features for lighting applications, though it is a general-purpose board and provides a compact platform for other projects as well. It's ideal for modernizing old lamps and creating wall fixtures with home automation. It will control both high-power white and RGB LEDs. The encoder knob is used for local control. It can also be controlled with the serial network here. And there are pins down here that can be connected to a motion sensor for different ways of controlling it. It comes pre-programmed with a sample sketch that makes use of all the features to get you started quickly, which I'll show later on. The board has 3 outputs for RGB LEDs at 1.4 amps each, with an additional 5 amp channel normally for higher power white LEDs. There's an extra pin header that can be used for an additional PWM LED driver. This might be useful for a lamp that has both LEDs to light the ceiling and also downward task lighting. The RS485 network interface can be used to control the outputs and also receive data from the motion sensor, which is these pins here. There's a built-in power supply that can accept either AC or DC on these top 2 pins here. Up to 31 volts DC or 22 volts AC can be supplied. The bottom 2 pins are for +5 VCC rail and ground connection. See the technical page link in the description for more details. The processor, this little square here, is an Atmega 328PB version, which has new features and additional ports over the 328P version that are very common. The MCU has touch inputs, additional communication ports, and counters/timers. See the link below to a document describing the differences with this new PB version of the chip. The board has a 6-pin style ISP header for programming. Search online for USB ISP and you will find many low-cost programmers available, many for less than $10. The 6-pin style is common, though many come with a 10-pin connector. You will find 10 to 6-pin adapters, or you can make your own. On your Arduino IDE desktop environment, select USB ISP as shown. Command line users can use the -C USB ISP with the AVRDUDE command. One more note about Arduino IDE. The Atmega 328PB chip is new and may not be supported directly yet. The Arduino package called MiniCore can be installed. Then this chip will appear on the Arduino tools menus. And if you use AVRDUDE, you can use the -P Atmega 328PB option. On the back of the board, there are extra pads for all of the LEDs in case you want to solder directly onto the board instead of using the pin sockets on the front. Pads for the white LEDs are here and here, which can supply up to 5 amps, and that's more current than the pin header type connectors can handle. So for higher current, you probably want to solder directly onto these pads. LED strips come in a wide variety of density and LED combinations. This RGBW type of LED strip has both the white LED here and then an RGB LED over here. I have a test setup here with separate RGB and white LEDs on separate strips, and I've also added a divider to make the light more distinct. First I'll add a diffuser over the LEDs so that the camera doesn't get swamped. I'm going to plug it in. I have all the LEDs wired to the pin out on the pin strips. Now we'll power it up. I have the lights dimmed a little bit to make it more visible. You'll see all the LEDs come on, and you'll see the indicator light flash a bunch of times, and then it dims down, leaving it green. The way the pre-installed sketch works is that there are several modes. Pressing the knob changes between mode 1, 2, or 3. The indicator light flashes with the mode number. The board is normally in mode 1. That means changing the knob will change the white light just as a desk lamp, as you would expect. When you push the button, it will go to mode 2, and now the knob controls the RGB color. And when you push the button again, it will go into mode 3, and that changes the brightness of the RGB. And if you push it a third time, it will go back to mode 1, and you're back to controlling the white light. There are 2 special modes. The first special mode turns all the LEDs off, like if you're going to bed and you just want to turn everything off. You hold the button down. When it flashes one long pulse, then you let go and everything turns off. If you hold the button down and wait for 2 long pulses, then it goes into color changing mode. So I'll demonstrate that. 1 long pulse, they all go off. You can turn on the LEDs again, change the color, and now if we hold it down, 1, 2, and let go, now it goes into color changing mode. After a few minutes with no activity, Mode 1 will automatically be selected. This is because most people will expect the white light to be controlled if they just walk over to the lamp. There's also an extra special mode useful for testing. After your LEDs are connected to the board, you may want to know how much power is drawn. This will set all outputs to 100% for a few seconds, enough to get a reading with your meter. In this version of the built-in sketch, the LEDs will dim automatically if a motion sensor is connected. After the sensor input changes as someone is leaving the room, followed by several minutes of inactivity, the outputs will gradually dim to 10%. When somebody enters the room, the RGB LEDs will return to their previous values. The color changing mode is not affected. You can use the newer type radar sensors or the older passive infrared PIR type. Some sensors can be wired directly, though be careful to check before connecting. Some 12-volt PIR sensors may actually output 12 volts on the sense line. An opto-isolator can be used, especially if the sensor is some distance away to prevent picking up other electrical noise. There are also PIR sensors that use 120 volts, but we recommend not using these. The RS-45 network can receive and send control and data messages. If the motion sensor detects someone, a message will be sent from the SmartLamp Controller. These messages are only a few bytes long. There are commands that you can send to the SmartLamp Controller to activate any of the LEDs and modes. Details on the networking will be shown in an upcoming video. As always, check the video description for more details. I hope you find this project useful, or at least entertaining. Watch for upcoming videos on putting the SmartLamp Controller to use in the real world. The SmartLamp Controller is available through the links below in the video description. We also offer engineering services and are able to design and produce custom units if you have special requirements. Our contact information is below. Please consider leaving a comment since this will help us make future videos better.